up and running. So I guess let me just start by saying that I'm really excited to see some new faces, some familiar faces, and our group get together again in person. It's really fantastic. So thank you guys for organizing that. My name is Patrick. I am the mobile chapter lead at Flybys. I am also the organizer of the Melbourne TensorFlow user group here. I am a member of the TensorFlow JS and TensorFlow Lite working groups at Google, and also a founding member of the special interest group for JavaScript at the TensorFlow team. This doesn't make me an expert, it just makes me a really time-poor person. I guess in today's talk, I'm really going to provide you with a very quick, high-level coverage of everything new that was announced around AI and machine learning at Google I/O. And I just try to focus really on what is relevant to us as developers. So at the keynote, Google showed the fully open source ecosystem that takes you from end to end with AI and machine learning. There are developer tools for managing your data, training your models, deploying them to a variety of services, all the way from cloud to microcontrollers, and of course, ways to monitor and maintain your systems with machine learning operations. At the start of every machine learning project is the gathering and management of data. Google has a lot of tools available for us to do that, but there's only one thing that really stood out for me from the entire presentation, and that was TensorFlow datasets. So TensorFlow datasets is a collection of ready-to-use datasets published by Google and the community. They can be accessed by using only a couple of lines of code, and they're incredibly useful for prototyping a model. And essentially what that means is this is an example for using the Cassava dataset to create a model that can predict crop disease. It can be used to evaluate model performance and performance and inference before spending a lot of time to build the data, train your data, and label it for your project. So if you have the project that is relevant to something like this, you don't have to spend time creating the data. You can just evaluate the model immediately here. So I would really highly encourage everyone to have a look at the available datasets and use them either for learning or for your next project. Now, when it comes to training a model, especially if you focus on mobile and embedded devices, you can use the TensorFlow Lite Model Maker. So as the name actually suggests, it is a tool that aims to assist with the complex task of model creation, such as data processing, training, evaluation, and optimization. By using the available APIs, you can reduce the code that is required to build this model from something like this that we see here into this screen to this. So so obviously that makes the whole implementation much simpler. And as developers, it's quite easy for us to understand, right? All we're doing here is pretty much importing our data, splitting it into a training set and a test data set, and then train our model and classify it. And while we're on the subject of model deployment on the mobile, we now have the public beta of TensorFlow Lite in Google Play services. It is a service that was created directly from feedback that came from developers to Google. It reduces the burden of deploying the TensorFlow runtime and the model every time we have to do updates. So that reduces the amount of releases we have to do for the app. And because it is serving it, it also reduces significantly the size of the APK file. This way, we are always certain now that our users will be using the latest version of the framework and the latest version of our machine learning model. And while it's still early in public beta, doesn't mean that it's unverified. It's already being used by Google teams, especially the MLKit team, and it's performing 400 million. It has 400 active million users and performing 20 billion daily inferences on the service. Moving on a little bit from mobile to web, I think I have not seen an explosion of use of machine learning into web more than I have seen this year. It just seems to me like it literally blossomed out of nowhere. TensorFlow JS is Google's machine library for JavaScript for the web developers in the crowd. And it's just like the original version of TensorFlow that was built for Python, but now it is aimed for people that obviously work with JavaScript instead. From client side to server side, mobile native, desktop native, and even IoT devices like Raspberry Pi, JavaScript is one of the most used languages across all those devices and surfaces. And there is another big advantage when we actually use JavaScript for machine learning: privacy. Because we don't have to send any of the sensor data out into the cloud in order to perform inference, because it's all running natively on those devices. Now, if you want to learn more about how to do, build some projects with TensorFlow.js, Google have just recently launched a brand new course on EDX, where you can go from zero to hero with machine learning in JavaScript and bring your creative ideas to life. I recently completed that course, and it's great, dependent of where you are in your journey as a developer, whether you're a beginner or not. It covers quite a lot of subjects, so I would really, really highly recommend it. Also now, sticking a little bit to TensorFlow.js, some of you may remember the launch of the Coral Edge TPU in last year's Google I/O. Following quite a few requests again from the community, Google now announced the launch of the Coral Edge TPU support in Node.js. That's actually done by a special library, which I'm not going to attempt to pronounce. It's really right up there. And this pretty much allows JavaScript developers to load any TF-Lite module into the project and execute it on the connected TPU. It's a tiny little device, really, just almost like a thumbstick. So if you want something like a Raspberry Pi or another kind of like micro-power connected device, definitely something that can help you run some more heavy models and training onto that. And sorry, just to clarify, the difference between TensorFlow.js and TensorFlow Lite is TensorFlow Lite normally caters for mobile devices and things, so it requires quite a bit more GPU and CPU, as opposed to the TensorFlow.js, which is restricted to just the memory and capacity that we have within the browser itself. So this is a way to boost basically our TensorFlow.js projects. Now, on this slide, you can actually see all the models that have been released, with several updates for 2022 that are highlighted in bold over there. They can be used across many areas, like vision, body understanding, text, and sound. But what's actually really new in 2022, first up is the selfie depth estimation model. It's capable of estimating the distance from the pixel to the camera for every image. As you can see on this slide here, for example, from an image, you can almost get a depth understanding. If you can understand the depth of the human body in an image, you can do some pretty impressive stuff. For example, you can enable 3D photos live into the browser. Right? It's a single image, literally, that's passed through here through the selfie depth estimation model and allows you to produce such subtle 3D effect. Yeah, I know. It's kind of like funny. I don't know how many use cases you have, but you can actually convert your images to something that is 3D, right? Or image relighting. I thought that was a little bit more weird, but if you really want to, push light into your images from different angles, you can do that now because you obviously have depth. You can see the light coming in from the back or from the side. And the next, model that came up is the launch of the 3D pose estimation, and that happened with collaboration with MediaPipe. It can estimate 33 key points on the human body and can do that in real time. It has three forms. It has a light form, a full form, and a really heavy form. And it allows you to select whichever one you want between a trade-off of accuracy and speed of execution, depending on what you want to do in your project. And then something that I thought that was quite interesting as well, since you obviously can do that now, we've seen the VTuber community adopt that and start embracing it, and they started creating the new 3D avatars, which can be, displayed in virtual meetings or streams or events, in real time using the specific model. That's what I said at the beginning. People get very, very creative with JavaScript now. And of course, continuing that from the MediaPipe collaboration, there's also the release of a brand new body segmentation model. It detects the frame of the human body, but also segments it from the actual background. And a real use case for this is actually that another version of that model is optimized for selfie segmentation, and it allows you to create the background effect that we can see here in this video. As a matter of fact, this model is just a slightly modified version of what Google is using for all the Meet interfaces. We also had updates to the hand pose model, and now it enables tracking of multiple hands, not just one, and you can do that simultaneously in 3D or 2D with a higher precision than before, which is great. And as you can see, probably, like in the image, great for, understanding like sign language or building something around that. Now, we also had a bit of new hardware announced at the Google I/O. We had the announcement of the Coral Dev Board Micro. As you can see, it's a very, very small factor microcontroller. And what makes it different from other microcontrollers in the industry, because let's face it, there are quite a lot, is its dual mode application flexibility. And what I mean by that is that it can use the M4 core to run very, very lightweight TF-Lite micro models. And when there is a need to switch into something that is more high performance, detects a change, then it seamlessly switches to the M7 core and can run a high performance TF-Lite model. So what this means, if you consider like almost like a scenario whereby you have like a camera that does detection, you can have a micro device running in really low power mode, just looking at the background in general, not performing barely any inference. And when something pops into the screen, you suddenly switch into the most high powered model and like execute what you need to execute. So lots of good use cases. It can be battery powered. It is compatible with the Arduino SDK, and it has an onboard camera and microphone, so you can use it for either vision or audio ML applications. Now, if you do manage to get your hands on one of them, please call me. It's going to be probably highly unlikely, but if you do get that chance and you do want to try it out, you'll need to do so on a Linux device, and you have to use either the traditional C++ approach, or like if you're more familiar, the Arduino CLI. And we also have like a kind of like a set of new models and frameworks. And we start a little bit with generative language models and the now famous Lambda model. If you don't know why Lambda is famous, let's talk about it over drinks. So these models are able to produce text about anything really by recognizing patterns in the language. And to experiment a little bit more with them, Google has given us three little demos where it's almost behaving like a chatbot, where you give it input and it generates a dialogue with you. So they've done 3 little demos at the moment, where it is you can ask it to imagine something for you, create potentially a list for you, or just have a general chat. The next one is my personal favorite, Imagen. Right? It's an AI system that creates photorealistic images from text input. So the photos that you actually see on this slide is not real. It was generated by the AI system simply by putting in the text that you can see below, a kid corgi in a house made of sushi. So, good luck for us differentiating what's real and not real, moving forward. And finally, we're probably going to come back and say that we saw the popularity of JAX grow a little bit. JAX is another open source framework for machine learning by Google. It is like TensorFlow, but it's predominantly targeted for researchers and research, and it aims to provide a bit more flexibility and lower level APIs so that they can build their own algorithms. And the nice thing on top of that is that we had JAX, which then provides the high level APIs on top of Flux. It's almost a little bit like what Keras is for TensorFlow. And that is really all the things that I wanted to cover. Do you have any questions?